Hello everyone. In this problem, we want to draw a phase diagram of oxidation of pure iron. So, in our phase diagram, we will vary the partial pressure of oxygen in one axis and the temperature in other axis, and we want to see what type of oxide and steel phases or iron phases which will form due to the variation of this oxygen's partial pressure and temperature. In order to calculate this type of phase diagram, we have to select three different databases. First, which is FS steel, which incorporates all the steel phases. Then FT oxide, which incorporates all the oxide phases. And FACT-PS, which incorporates all the gases and the pure compounds. So first, we want to open FactSage for doing this type of calculation. As we open FactSage, we have to go to phase diagram module and left mouse click on this phase diagram button. Here, when the phase diagram dialog box opens, we have to first select the databases. As we discussed before, we select FACT-PS, FT oxide, and FS steel to incorporate all the steel phases, all the oxide phases, and all the gaseous and pure compounds. After selecting all the databases, we'll click OK and then input all our reactants. To input all the reactant species, we go to this plus button and then left mouse click on it. In this phase diagram of this pure iron oxidation problem, we have oxygen and iron. So we'll input oxygen and iron as reactants. Then we click on next button and we will reach the menu window. Here we'll click on, we want to take all the solution phases, and to select all solution phases at a single go, we go to this select button and left mouse click on this and then select all solution. Also, we want to select pure solids. To do that, we just go to pure solids and click here. To check what pure solids we have taken, go to pure solids, this text, and right mouse click on this. Here we can see this green selected pure compounds which we have taken. After selecting all the desired pure compounds, then we click on OK. Then we want to go to this gray area to input all the axis information. We left mouse click on this area and this variables dialog box opens. Here we want to vary the temperature and the partial pressure of oxygen for this oxidation diagram. To vary any gaseous partial pressure, we have to put 1 in this area, and we don't want to vary any compositions, so we put 0. Then go to click on this area and go to next. Now we want to change our temperature and use the temperature to vary in x-axis. In order to do that, we have to go in this area and click on this drop down menu. and select x-axis. We want to vary the temperature from 500 degrees centigrade to 1700 degrees centigrade, and we want to vary the oxygen's partial pressure. To do that, we have to go to this area and click on this drop down menu and select as y-axis. We want to vary the partial pressure of oxygen from minus 40 10 to the power minus 40 atm to 10 to the power 10 to the power 0 atm. In log scale, we put minus 40 to 0, and then after putting all the information of axis and the variables, click on OK, and then to draw the phase diagram, we have to click on calculate. Now FactSage draws the phase diagram with temperature in our x-axis and variation of partial pressure of oxygen as y-axis. In order to see which area corresponds to which phases, we just left mouse click on this area to see what are the phases corresponding to that area. So this is how we draw the oxidation phase diagram of pure iron with varying partial pressure of oxygen and temperature. For our next problem, we want to draw a phase diagram which is an oxidation diagram of iron chromium alloys, where we want to vary the partial pressure of oxygen and the chromium composition, which is X, in our phase diagram, and see what are the phases which evolves due to variation of these variables. So in order to do that, similar to the previous problem, we first want to open FactSage. In FactSage, we open phase diagram. In phase diagram, we first select the databases which we require for this calculation. We take FactPS, FT oxide for all the oxide phases, and FS steel for all the steel phases, and FactPS for gases and pure compounds, and then we click OK. After that, we want to input all the reactant species. To do that, we left mouse click on this Add New Reactant button. In this case, we have oxygen, we have iron, and we have chromium. After inputting all the reactant species, we'll go to Next. Here, first we'll select all the solution phases. To select it at once, we'll go to the Select button and click left mouse click on it and select all solutions. And also we want to select all the pure solids. We go and left click on this white area. Then we want to specify our variables which we take in our x and y axis of the phase diagram. So we go in the gray area and do left mouse click button. Then this variable dialog box opens. Now in this case we want to vary the partial pressure of oxygen and the chromium concentration as our x and y and x axis. So we put one here and one here, go here and click next. In this case, our In this case, our temperature is not varying. So we fix the temperature. To do that, go to this x-axis area and click on the drop-down menu and select constant. For this problem, we will take the temperature which is fixed to be 1200 degrees centigrade, and then we also want to vary the partial pressure of oxygen in our y-axis. So click on this drop down menu and select y-axis, and we want to vary our partial pressure in log scale from -20 to 0. We put the value here, and we want to change our chromium concentration as varied in x-axis. So click on the drop down menu and select x-axis, and then we want to vary the chromium composition. So put 0 in iron and 1 in chromium, and this is the mass fraction from 0 to 1. After putting all the variable values and all the data required for the phase diagram, we click on OK, and then to get the phase diagram, we click on left mouse click on calculate. Here you can see Faxes has calculated the phase diagram with partial pressure of oxygen in log scale in our y-axis and chromium mass fraction in our x-axis. In order to check which phases are formed, we left mouse click on the phase areas and that is how we can calculate the phase oxidation phase diagram of iron chromium alloy with varying partial pressure of oxygen and the chromium amount in the alloy.